Okay, this is question form page 356. It says, this is the graph of y equals x cubed minus 2x squared. Fair enough. Please note x cubed, it's the characteristic, hump down and round again. It's, giveaway shape. And I've got to sketch each of these graphs. What I've done, of course, is I've got 4 screenshots, one for each of these graphs. If we study the original, that's the original y equals some function of x. It's been defined as x cubed minus 2x squared, and I've got to somehow get this out of it. Well, fair enough. X cubed matches, minus 2x squared matches. That's my original f of x, and then I've got to just add 2. What does that mean? I'll take my f of x, then add 2. In other words, lift it up in the air 2 units. Now, I've been given coordinates to help me sketch it relatively accurately, so if I'm lifting the whole thing up 2 units, in other words, if I'm translating it using vector 0, 2, then I can use the coordinates to help me. So 0, 0 becomes 0, 2, 1 minus 1 becomes 1, 1, 2, nothing becomes 2, nothing. Let's have a look. No, it becomes 2, 2, sorry, and 3, 9 becomes 3, 11 up there somewhere. 1 minus 3 becomes 1 minus 1, about there. So now I've got to try and draw this wonderful thing and try and make it look great. So let's just have a look at that then, shall we? So up, peak at 0, 2, back down to 1, 1, round to 2, 2, and oops, have a go. Or should take off up there somewhere. It's not supposed to actually cross over the red line. Let's get rid of this little mess here. Should really continue on the inside, but just stretch up like that. That's the best I can do, really. So that's the graph of y equals, here it is, y equals x cubed minus 2x squared plus 2, and that's the 2, make it look very pretty, and that's the important part of the plus 2, which means lift it up in the air using 2 by 2 units. So I went translation using vector. Doesn't say I've got to do this, but this is good revision, using vector 0, 2. Alright, so up we went, plus 2 up in the air. And that's that. Again, this is good practice. If it asks us to do an exam, please do this. It's 3 marks sitting there looking at you, so let's just practice it. The next one, fresh page, x cubed matches, minus 2x squared matches, minus 1 is the operational bit. So I'm looking at y equals some sort of function of x, and then take away 1. Essentially drop the graph down, and again I'm going to be using translation vector. 0 minus 1, which means drop the graph down 1 unit. Alright, so let's just make that look pretty. So 1 minus 1 becomes 1 minus 2, 2 0 becomes 2 minus 1. What else we got? 3 9 becomes 3 8. 0 0 0 minus 1, and that goes to 1 minus 4. So it's effectively this sort of arrangement. So here we go. Hit that, hit that, hit that, hit that, and then stay on the outside of the graph and do the best I can. Far from perfect. Let's just try and do that a little bit better. Really hard to do this. No, not better at all. Anyway, what I've done is I've dropped below each point. I've tried to drop below anyway each point, but that's the transformation that I've done. And yeah, that shouldn't be touching really, to try and make that look even better. It makes it look brilliant. So that's going to be minus 1 minus 4. It should be more like this. I still managed to touch it. Anyway, so just drop below 1 unit in each case, draw around, and there's your curve. Effectively translate the original red curve of x cubed minus 2x squared, drop it 1 unit, and try to take each coordinate down 1 unit and redraw it. That's all I can do really. Next one. Right, done that and done that. Next one, y equals 2x cubed. I've got 1x cubed there, and minus 4x squared. I've got minus 2x squared. So let's just write down the original, see how they compare. So y equals x cubed minus 2x squared. So that's my original y equals function of x. This one, I've got y equals 2x cubed minus 4x squared. Have them side by side, you can compare them. If I factorize that, I therefore get 2 bracket x cubed minus 2x squared. And now this part of the transform graph exactly matches the original function of x. So what I've got effectively, I have y equals 2 lots of the function of x. Now if you recall, generically y equals a f of x, and the a of course is 2, as I've highlighted a minute ago, and therefore what you do, you leave the x coordinate all on its own and you multiply the y coordinate by 2. Okay, so here we go. Multiply the y coordinate by 2, because that's the a value, and you leave the x coordinate unchanged. So let's try and do that. What's the net effect of that? The net effect is that you get the graph and you stretch it in the y direction by scale factor 2. So I think I'll write it down. So it's a stretch. Try to look pretty. Stretch. You can see. So stretch in the y direction using scale factor 2. Alright, so let's have a look. Let's try and do it then. So 1 minus 1 becomes 1 minus 2, and 2 0 remains as 2 0. 1 minus 3 becomes 1 minus 6, which is way down here somewhere. Oh, it's going to be really hard to draw this. How do you do this? So 2 0 still remains as 2 0. So I'm going to go up here, and 0 0 becomes 0 0 again. So really hard. 3 9 will become 3 18. So that's going to be flying off up here somewhere. Essentially, I'm going to get this. This coordinate is acceptable. Pass through 0 0. Come back down to 1 minus 2. Pass through 2 0, and then accelerate up here towards, off the page now, towards 3 18. Well, of course I can't get it on there, but look, if you look at the positioning of it, so it's inside the first curve, hit 0 0, drop below 1 minus 1 to 1 minus 2, because I'm multiplying by times 2 in the y direction, then up through 2 0, and off we go. And that's the best I can do, and that's that one done. Now the last one, let's look at it carefully. The original function is as follows: y equals x cubed minus 2x squared, and that's my original y equals f of x. Now this is my graph for D. I've got y equals 2x squared minus x cubed. Look at it carefully. They're very similar. Let me write it around the other way. Y equals minus x cubed plus 2x squared, and they're looking really similar now. Look at that. X cubed minus 2x squared minus x cubed plus 2x squared. So I've almost finished transforming the thing. Now, if I factorize it, I'm going to get y equals minus, open bracket, x cubed minus 2x squared. And now, this bracketed part of the transformation exactly matches the original function, the original f of x. So what have I got now? I've got y equals minus my original function. See, now it becomes very clear. I take this complicated function, I minus the function, minus f of x compared to my original f of x, and you may recall that that minus means reflect in the x-axis. So it's a reflection in the x-axis. That's my last transformation. So it's quite easy to do. Work with blue. 1 minus 1 becomes 1 1. Of course 0 0 and 2 0 stay where they are. 3 9 becomes 3 minus 9, way off the bottom here somewhere, and 1 minus 3 becomes 1 3. So now I've got to try and get this thing sorted. So here I go. Pass it through here, 0 0, 1 1, 2 0, and drop it all the way down off the screen and off the page. So that's a very crude reflection. I reckon I could do this little bit a bit better. That's definitely got to pass through 0 0 like that, and I'm happy with that. That's the reflection. Okay, so what did I do? I took my original transformation, wrote it down. My original function, wrote it down. Wrote down the intended target graph, and then gradually compared it with the original, transformed it, factorized it, and then once I factorized it, I could see that this minus is the minus there in front of the original function, which means reflect it. And once I've realised that, I can then just draw the reflection quite easily using the few guided coordinates to help me. And that's it. That's question 4. Not too tricky. Still grade A star though, but there you are. That's the end of that one. And now I'm going to prepare question 5.